It's been a while I've recorded a video, so I just decided I should go ahead and do it now. So in this new playlist, the plan is to analyze different data sets. I'll take a data set, build a model, just play around with it so that you can have experience on how to do it yourself. So I've installed, all the standard libraries, pandas, Seaborn, scikit-learn, and everything you can use for a typical data science project. What I'm starting with now is the very, interesting and simple Auto MPG dataset here. So I can open it. So it's just, very basic. You have data on the miles per gallon, the number of cylinders, the displacement, the horsepower, weight, acceleration, the model year, origin, and the car name. Let's see how we can build a model to predict the horsepower out of a vehicle based on all the other factors. Or we can do it the other way around. We can predict the miles per gallon for a vehicle based on all the other factors. Yeah, let's do that. Let's predict the miles per gallon. So this is, our target, and these are our input variables. Let me just show you how I approach this problem. Let's rename it, say Auto MPG. So please comment below any data set you want me to analyze and let me know what you want me to do. If it's regression, if it's classification, if it's image classification, things like that. Just put it down in the comments and I'll see if I'll get to it. So first thing you want to do is you want to import the libraries. Okay, so let's import pandas, import numpy, import Seaborn. Okay, this should do now. We can always come back up and add more stuff. Let's put in the data frame. I'm going to use the pandas read CSV function. So in a typical, data science project, when you do get a job, this is actually, for the most part, this is what you're going to be doing. You're going to have some data sets and you're going to go ahead and analyze that data set. That's pretty much what it is. So the idea here is just to see how an experienced data scientist would approach a certain problem. Okay, so let me do this. I haven't released the video in a while. It's been a very long time. I think a little bit over a month because I've just been, I have a baby girl now. Little girl, she's about 3 months, and it's just interesting, but I'm getting back into it and I plan to be more regular with my postings from now on. So that's why I'm starting this brand new playlist. But you can also check my other playlist that's going to be in the description below. One thing I like to do when I start a project like this is to look at the data set and just see a basic description. So I can see the miles per gallon here, the cylinders, the displacement, the horsepower, model year, the acceleration, the weight, and the origin. Yeah, so this is what I can see. Let's see what the head of it looks like. So just df.head. Of course, because I'm in a Jupyter environment, I don't need to use a print statement. Okay. Now this is totally unnecessary, but that's fine. So this is what we want to predict, the miles per gallon. So let's just put a header on top here, make it a markdown cell. Predict MPG for vehicles in this data set. Okay. The first thing I'd do in a case like this once I have a particular target variable is I'm going to go ahead and look at what's the distribution of my target, right? So we can say, let's just name this exploratory analysis, make it very nice. Okay. For this, I'm going to use Seaborn. I do have a playlist on how to use Plotly Express for visualizations, but I'm not going to use Plotly in this case. But Plotly is really nice. You'd like it. I also have a Udemy course as well. So exploratory data analysis. Let's look at the distribution of miles per gallon. Okay, so I want the MPG. Okay, yeah, so that's the thing with Seaborn. It kind of looks ugly sometimes, but it's fine. I'm not presenting this to business folks right now. So you can see the distribution of the miles per gallon goes from between 10 miles per gallon to a little over 40. Okay, so next we want to see, okay, for the features in this data set, how do they relate with this target? So we can see there's a pretty good spread on the target variable. Okay, so now let's go ahead and look at the description. So for the miles per gallon, we know the average, which is the mean, is 23, the standard deviation of 7, the minimum is a 9, the maximum is a 46. For the cylinders, we have all of this. We have some, cars with 8 cylinders. The mean in this case doesn't really matter because this is more of a, you can have 5.5 cylinders, right? So it's usually a whole number. But that's good to know that that's what the average cylinder in this is. Displacement. So this is pretty much just the size of, the engine itself, the horsepower, the weight, acceleration, model year, origin. Okay. First thing first, let's just, have a nice plot, see how the plots relate to the target. Okay, how can I do this? Just put 2 hashes in front. Yeah, that way it's big enough, but not as big as the first one. Okay, so let's say we want to go through everything, right? But we don't want to plot. There are some files that we don't want to have to plot here. So first thing, let's drop this unnamed 0. Don't know why it's there. We don't need that. We also don't need the car name. So I'm going to drop those 2. Okay. Let me do that right here instead. Put that. Okay. I forgot to add the axis. Because I'm dropping it along the columns and not the rows. So 1 is for columns, then 0 is for rows. And we can do in place is true. So I want it to be dropped in place. That's what we have there. Next, I can just go ahead and just create scatter plots. So I want to plot every column in the data set. So it goes through each of them and it makes a plot. Scatter plot. Yeah, my autocomplete is not working today. So I want the column on the x-axis. Okay, well, this is fine. It's not going to be pretty, but oh yeah, I need to import the matplotlib thing. Hopefully I've installed it. Did I install it? Let's go. I believe it should be installed. It's fine. From matplotlib, I can just do it this other way. Import matplotlib py plot as plt. All right, so this should not be a problem. Okay, so this is just a future warning telling me how would prefer I do this. So I could just rearrange this, is fine. Let me not make Seaborn mad. So I could just say I want this as my y. I want this as my, I want my x as column. Okay, and I want the data to be the data frame there. So let's do that. We shouldn't have that error anymore. So of course, when you look at this, you can clearly see that, you know, we have the miles per gallon here against itself, and of course it's a straight line for the along the 45-degree angle because you're plotting against itself. For the cylinders, you can't really see a relationship here. You can see there are some different mile per gallon values along, you know, the 8 cylinder, the 6, the 5, 4, and 3. You know, so it's pretty, you know, difficult to tell because there are some 3-cylinder cars that have much poorer MPG than some 4-cylinder cars. Okay, now this is good and interesting because we can see an inverse relationship between the displacement, that's the size of the engine, and the miles per gallon. We see something similar with the horsepower, and you know, both of them tend to trend this way as well. So in my case, it would be best, even this, the weight, right? You can see these three trend very similarly, and they seem to be highly correlated. We don't need to use all three when making a model. Now, this has a different relationship. It's hard to tell, you know, what the, it's not, you can't really say that it's a direct one, although it tends to be, but the correlation will, from what I can see, it's not going to be a very strong, it's a positive correlation, but it's not going to be a very strong positive correlation. Model year doesn't really have much effect. You can see it's just nominal. And then the origin. Okay, so generally you can see cars from origin 1, you know, they tend to have this kind of, you know, there seems to be like an upward trend, sort of, you know. Yeah, so that's what it is. Now to pick the features, you see. So if we're just to do a base model, right, and this is a wrong thing to do, is to just use all the features. And that's obviously a bad idea, but you know, I'll just do it and show you. But for that, we're going to use linear models. Okay, so let's import, let's add stuff here. So from sklearn, that's scikit-learn dot linear models. Yeah, something's really going on today with my autocomplete. So for this, ideally, we can see that there's a correlation between these three because they pretty much have the same pattern. So there's not much benefit to just including all of them together. You understand? So let's go ahead and include just one. But let me confirm, let me show you that with just correlation. So let's look at the correlation. I like to do the Spearman method. Okay, so we can see that with the MPG, so let's say horsepower and weight, you can see they're highly correlated. And of course, that's, you know, of course, weight was one of them, horsepower. So let's say horsepower and displacement. I'm sure we're going to see something similar. Horsepower and displacement, highly correlated. Okay, so let's check, you know, the correlation with the target itself. So displacement, horsepower, weight are pretty much, you know, the same. You can see 85, 85, 87. Model year, it says there's a 0.5 correlation, which of course, when we check this, you can see that, yeah, generally the mass per gallon improves, with the years. That's something you can definitely see, right? It's that, okay, as we go from the 1970 all the way to 1982, in general, the mass per gallon tends to improve. And that's, of course, due to, let's say, better, regulation. That's the word I was looking for. Okay, so let's see cylinders. There seems to be a negative correlation. Yeah, kind of, sort of, but not quite. Displacement per acceleration. Now you can see it's positive, like I said previously, but it's kind of weak. It's a weak positive correlation, generally speaking. Okay, and that's what you see here. It's like, yeah, there's something, but not really, So it's not something I'll really include in my feature set just like that. And of course, if you check this, there are different, options you can use as the method. You can also use the Kaggle. Yes, we can change that. We should see something similar. Okay, so with that, you see horsepower, weight, and displacement all have, similar correlation. You can see they are all negative and about the same thing. So we're just going to pick one. Number of cylinders is a negative correlation. Acceleration here is positive, but weaker than what we had before. And yeah, that's pretty much what you see here. Yeah. So let's go ahead and just build the most basic model. I'll say like a naive model, like basic stuff. Okay. Okay, so basic model. We're just gonna do this the rough way. Yeah. Okay, we have that. And there's something I like to use in scikit-learn. It's, of course, we need to use, let me show you here. We need to use pre-processing steps. Okay. Let me just open this in a new tab. Go to pre-processing. Okay, so there are several methods. You can go to the pre-processing module. And you can see there are several of them. There is the standard scaler, which is the most common one most people use, and I use that as well. We could use this. So what this does is it changes every point to a z-score, and of course it helps in the optimization algorithm for each of these machine learning models. There are other options, max absolutes, there's a min max, there are several of them. But I just always use this one. Of course, I've used the others as well. And yeah, let's, the bad thing about the standard scaler though is it's easily affected by outliers, like outlier points. Let's just import that first. So now the reason why I'm showing you the documentation is so that for your project, you know where to go, for things like this. Okay, that's what we want. Standard scaler. Okay, let's just do that. Okay, we have that. One other thing which I find very useful is pipelines. I guess showing it would be better. So let's look at that. Pipelines. Well, okay, yeah. So this is a dataset transformations. this is what we're looking for. So I tend to use this make pipeline. Okay, but we have all these options. So pretty much what this pipeline module is, it helps you build utilities to develop composite estimators. So if you want to chain several things together, like standard scaling and things like that, you want to use pipelines. Okay, so let's just go there. We can show you how to use that, or we can use this as well. So how this works is this, right? We're going to use the pipeline function in the pipeline module in sklearn. And we're going to list the steps as a list. Okay, we're going to supply a list of, okay, what steps we want to be done. And as a list of tuples. So this is a very good example here. You see, we use this. So that's pretty much the same thing we're going to do. So let me import this as well, because we're going to use it. So from sklearn.pipeline pipeline, and we also need cross validation, right? So being able to split. So let me show you where you can get that. It is what we want for model selection, train test split. Okay, so let's import that as well. So first thing, after you've done, you've done your basic exploratory analysis, you've decided what features you want to use. What we're going to do now is just go ahead and split into training and test. Okay, so we're going to use the train test split function. Okay, this is what we're going to use, and see, this is an example on how to use it. For me, I don't like to type this, so I just copy this out. Saves me a whole lot of typing, whatnot. Okay. All right. Okay. Yes. So this is what we need. Let's separate out what our y is going to be and then drop it. So say y is the data frame, and it's the MPG value in the data frame. So next, once we get that, we want to drop MPG. The axis is equals to 1. I want it to be in place. Okay, good. So our y is going to be y in here, and our x okay, yeah, this should be fine. Yeah, it's fine. Just put it like this and it should be good. For some weird reason, I've always had that issue with the train test split function. It's weird. So usually when you're building a machine learning model, you don't just build one basic model, right? You build a bunch of them, and you select your model based on different things, like, okay, the different metrics. So since it's a regression problem, there are certain metrics we're interested in. Before we go into any of that, let's create a basic pipeline. So let's call it pipe. And we're going to use the pipelines function. Let me show you why I imported it. So over here, pipeline. Okay, cool. So we want to specify what the steps should be. So I like to do it this way sometimes. Okay, so let's just say scalar. So the first step is we want a scalar, and we want it to use the standard scalar function. Okay, because the tuple, we're going to put a comma at the back there. Okay, so that's what we have. We have that. Next, we want another tuple. In this case, we're going to use lasso CV, right? And we're just going to use the base parameters there, but we need to give it a name. Let's say lasso. Okay, then we put this behind, and we're good. We have our pipe, right? So essentially what this does is it goes through the stages of transformation. So it first does standard scaling and then does that. So what we would do now is we're going to go ahead and fit, instead of fitting like the lasso regressor directly, we're going to fit it to the X train and the Y train directly. So let's just do that. And this is the recommended way of creating your machine learning pipeline. So that way there's not going to be data leakage between your training and your test. Yeah. Okay, wow, that was fast. Okay, so now we have this. It was pretty fast, no issues. Now let's just do a test, right? So let's predict on, what we're trying to do now is predict on the tests. Okay, so let's just say this is I don't know, prediction. So we've gotten to a point where we have our predictions. Now we need to look at, our metrics. And for regression problems, let me show you. There are different kinds of metrics, for maybe you're doing classification or clustering or whatever, right? There are a bunch of them. But what we are concerned with for right now is this one. So we are concerned with things like the R square. We are concerned with the mean absolute error. There's also the mean absolute percentage error, mean squared error, mean absolute error. So these are the different metrics. Okay, so let's look at this one first. Mean absolute error. Okay, see how it's used in the example. So you pretty much just call, we can get all of this. Let me copy this code right here. Okay, come here. We also need the mean. We can go over what each of these metrics actually mean. So as an example, let me show you how it's being used. But for us, we're just going to go ahead and use it. So we fitted our estimator. In this case, we didn't do anything too fancy. We just put every single feature there. So we can go ahead now. We know what the model thinks the result should be. So for each of that, we can calculate. Okay, let me bring all these metrics that we have here. Let's copy it. Okay. If I want to, can I actually just put this all into a simple function? But let's just do it this way. So we need to specify what the true value is first and then what the prediction is. And we do know what the true value is. That's our Y test, right? So we can just copy this and see what the prediction is. Mean absolute percentage error, MAPE. Now for the moment of truth. Let's print this out. Okay, not bad. Not bad. Not bad at all. Okay, let's see. So this R square is the explained variance, right? So what this just shows you is the maximum it can be is a 1. So essentially what it's telling you is, okay, based on all of this, the features you've selected explain 79% of the variance. You can think of it like that. Now, if you get negative R square here, which trust me, I've seen negative R square before, that's a bad model. You get 0, it means the model is just guessing. So you want this to be as close to 1 as possible. Okay. Now the mean average error. Now this is a very interesting metric because it says what it essentially means on average, your result is going to be plus or minus 2.5 off. So it's the mean absolute error, right? So it's not looking at whether it's not looking at the sign. So what that means is whatever you predict from this model is could possibly be off by plus or minus 2.54 for miles per gallon. Then the mean squared error. Okay, mean squared error in this case is 10. So it's saying, okay, every error, I squared it and I found the mean. So this is not necessarily in the units of, like in this case, miles per gallon. It's just saying, okay, this is, whenever I square the error, this is what the average error is. You want this to be as low as possible. You want this to be as low as possible. You want this to be as close to 1 as possible. So let's say the mean average percentage error. So its mean absolute percentage error is off by 12% error, which isn't bad. It's not bad per se. So that being said, we have this result. So these metrics are great, right? Now let's see, because this is a form of a linear model, we can see what weights was added to this, right? Okay. And that's why I like Lasso CV model, linear models, because it allows you to see what weight was added to, the solution. So for that, we're going to use the pipe. Let's see if we do steps. Okay. I want this second set over there. So this returns the list, right? And there are 2 items in the list, so 0, 1. Remember, lists in Python are 0 indexed. Okay, so this is what it is. But now this is a tuple, and I want the second item, which is this, right? So I can just go here and pick that. Okay, so I have the estimator, the Lasso CV itself, and I want the coefficients. Hopefully I didn't misspell something. I did. Okay. Okay, this is what I'm trying to show you. So under the attributes, coef, okay, 1f, my bad. So these are the different attributes available. Okay, let's see. So what this means is this shows the weights, but this doesn't make much sense to us right now until we pair this coefficients with the column names. Okay, so let's go ahead and do that. We have our X train. Okay, so that's a NumPy array right now. let's see, xtrain. I could have just done this, get it as a data frame. Still gonna work, so let's do that. So that we have access to the columns. So what I want is I want to make a data frame of both of them. Yeah, I want this to be the index. So let's copy this. But let me copy the data itself first. Just put that in here. Okay, cool. Now I want the index to be this. Okay. Want the index column. Okay, you can see this, and I can also specify what I want the columns to be. So let's say columns to be coefficient. Oh yeah, this should be a list. My bad. Can cut this in. Okay, so essentially what this is doing is it puts zero, it just zeroed out the number of cylinders and the displacement. Of course, it's put more weight on the weight function, less on the horsepower, and less on the acceleration. Then it puts some weight to the origin and the model year. So like I said, this is a bad, like in terms of the metrics, the R-square looks good, although I want it to be, much higher. I want this to be really low as well. This should be as low as you can possibly get it. But one key thing I want you to see here is, in a case where you have tags that are highly correlated, you want to pick just one of them. That's usually the best advice when you have multiple tags that are correlated like this. So horsepower, weight, displacement, you're just going to pick one. In this case, so this was the first iteration, right? The basic model. So let's build second model. Okay. Let's give it a markdown. Let's just say model 2. Now we're going to reuse a lot of this. So it does make sense to put, all this into a function. Ideally, that's what you want to do. But this is fine. We're going to use the same xtrain, xtest, and whatnot. We have all of that. Okay. Only thing is, we might want to drop some more features here. So let me just show you. I'm going to copy this. Okay. But now we're going to give it, let's say, pipe 2. So now I know it's not a very creative name, but yeah, it's going to still work anyway. So we're going to fit it. But before we do that, we're going to do something. So we want to drop certain features. So let's just call this xtrain2. It's going to be xtrain.drop. We want it to drop a list of, so we want to drop, let's drop the acceleration, no, not the acceleration, sorry, the displacement and the horsepower. Okay, let's drop those two. So let me just copy, this. Displacement and the horsepower. We can do this. Okay. And we want it to be dropped across the column. So want the axis to be equals to 1, and then instead we train on 2. Okay, so let's do that. Y train doesn't change. Awesome. Oh, my bad. This is sorry. Need to change this to pipe 2. Okay. Okay, next we need to drop this exact same thing on the X test as well, because they need to match. So let's do that here. Okay. Test 2. Okay, let's run this again. So that way we are gonna look at, we can do prediction 2 and the metrics. I'm just gonna copy everything 1. Change the necessary files. Oops. Yeah, I'm just too lazy to type. That's my problem. It's one of my problems in life. Okay, so let's do this. Cut this. Just like to be quick. Okay, so let's call this prediction 2 so it doesn't, I want to test it on 2. So this is 2 2 2 2 should we change this or should we not change it? Let's change it. Okay, just put the underscore 2 there and we'll see. So I'm doing this live. I didn't go through this model first because I want to show you just how I would approach this if I were to do this myself. So let's see what the R-square is. You can see the R-square improved. Okay, let's see what the error is. 2.5. Yeah, that didn't change too much. Okay, so what changed? Generally, it got a little bit better. Like, it's not something that's gonna wow me over, but it did get a little bit better. Let's see what the coefficients look like. Okay, so based on this, we could have, reduced some more features out of there, but let's see what the model feels are the important coefficients. So let's just do pipe 2. Remember, 2 in this case. See what the weights are. Okay, so that's what the weights look like. Okay, let's change this. Pipe 2. X train 2. So you can see here it puts absolutely no weight on the cylinders, puts little weight on the origin, the model year, even little less weight on the acceleration, and it just tags this along. So this is fine. There's still a lot more that can be done here, and this is where engineering new features can be very useful. Okay, so I'm going to just stop this right here, and in the next video I'll play around with more features, see how we can get a bit more creative, and then we'll just take it from there.